Hi everyone, welcome to this video on lesson 5 of the sound and light scheme. This is on properties of sound. This lesson is really all about introducing two words which are related to two other words, but the two main words we want to introduce are the science words, which are amplitude and frequency, and then the two other words are, as you might have guessed, loudness and volume and pitch. And these are two terms that any science teacher will know. Students constantly confused with one another. So the way we're going to introduce these two terms is by just changing one thing. So this is a very science way of doing things. If you've read Christian Moore Anderson, the biology teacher, he talks a lot about variation theory, and this is a really good example of variation theory as a means of teaching scientific concepts. But what we're going to do firstly is look at amplitude. So we need to keep everything the same except one thing. So we're going to use one tuning fork, and it's going to be the same. We're going to use the same surface to whack it on and so on. But in one case, we're just going to tap it quite gently. In the other case, we're going to absolutely whack it, and we're going to see the difference. So I'm going to talk this through to students. I'm going to say, okay, I've got this tuning fork. This is the one that I was using in the previous lesson. It's a nice large tuning fork. We'll come back to the size of it later, but right now I'm not interested in the size of it. But we've got this tuning fork, and the first thing I'm going to do is I'm just going to tap it. And again, this is where your classroom management is really important. You need absolute silence if this is going to work. So you get the whole class quiet and you go, okay, listen very carefully, and you just tap it. I don't know whether you're going to be able to pick up that sound on but you tap it and you get a very quiet but definitely audible note sounding from the tuning fork. Next thing you do, instead of tapping it, you whack it. So you go. And the first thing that we want students to be able to do is to associate the different motions, so the tap and the whack, with the different sounds, the quiet sound and the loud sound. Now you might want to take this a bit further by doing the tap and then holding it under the visualizer, and then doing the whack and holding it under the visualizer. Hopefully what they'll be able to see is a greater disturbance. So if I do a tap here, maybe it's vibrating a little bit, but not much at all. If I do the whack, it's pretty difficult to show. I'm not sure why that's not showing up as clearly as it was before. Let's just try that one more time. The whack. Yeah, so you can see the amplitude of oscillation is quite a bit larger. So I've introduced that word there, but what we want to do is illustrate what's going on here. So why is it different? So I'm going to show my tuning fork here under the visualizer. First thing we're going to do is write out the tap. So this is the tap. So this is when I tapped it. And what you want to show to students is that when I tapped it, the oscillations weren't that large. So I've got these kind of small oscillations, not a huge amount of energy. So when I zoom in on what's going on here, I can show this by saying, well, look, if this tuning fork doesn't have such a large vibration, it's just moving like that, then the impulse, or the whack, if you want to keep it, or the way it collides with the particles, whatever word you want to use, is going to be quite small. So I'm going to get relatively small oscillations if I just tap it. So I might just put small oscillations. Now note here, we're not bringing in wave traces at this point. We're trying to give a very kind of physical picture. This is in terms of our broader picture of waves being a disturbance in a medium. We know our medium, air in this case, is made up of particles, so we want to think, okay, let's think about the the size of the disturbance. So I might even put small disturbance, something like that. That would be fine as well, because we want to give them a physical picture, which we're then going to map onto a wave trace in the next lesson. So let's look at the next case here, the whack, and I'm going to use those words because they're really intuitive. Students will understand what you're talking about with those. And again, we're using that principle of concrete to abstract. So in this case, your disturbance is going to be a lot bigger. So I'm going to show this. I'm going to zoom in on the particles as follows. I'm going to show that in this case, my maximum disturbance, or what we might say later as a maximum displacement of my tuning fork, is going to be a lot bigger. Probably should have done 4 arrows there to keep it consistent, but anyway, don't worry too much. But what I want to show is the size of these oscillations or of this disturbance is a lot bigger. So the main thing is that I'm associating the tap with small oscillations and the whack with much larger oscillations. And I've shown that here as well, hopefully, oscillations, or if you want to put disturbance, that's fine as well. So in physical terms, that's what's going on. And then, hopefully, they'll be pretty happy with this. But what you want is for them to associate the tap, the small movement, with the small oscillations, and then, and I don't know whether you want to write this or not. It depends on your class, but you may want to add another note that just says quiet sound, because it's all about going from concrete to abstract and back to concrete again. And in this case, if we've got the whack and the larger oscillations, that gives us a loud sound. So it's associating what's going on physically with what we actually experience, what we actually hear. And again, this is a way of illustrating amplitude, but note, I've given no definition of amplitude yet. That's what I'm going to do when I've finished telling this story, finished drawing these pictures, is I might say something along the lines of, okay, if I tap it, I get these small oscillations, it's a small disturbance of air, that's why I get a quiet sound. And I would call that a low amplitude. If I whack it, I get these much larger oscillations, the air is disturbed a lot more, therefore I get a loud sound. That's what we call a large amplitude sound. So I can talk through this, and I can bring the word amplitude at the end. I might say something about, I might even just write it here, amplitude. I'm going to write that word down, but I don't necessarily want to give students all the answers, because I want them to be thinking about the pictures when they come to do the deliberate practice task later. Now I'm going to stop this video here just in the interest of time, and I would recommend you have a think about frequency before you then watch the next video, in which I will go through how I would illustrate the concept of frequency. So that will be the next video.